Welcome to today's session, everyone. Retrofit Roadmap, co-hosted by Retrofit Canada. We'll get started in 1 minute to just allow some participants to join. Okay, today's session is being recorded. We'll be sharing this recording on ENBIX in our resource library. We have a Q&A session at the end of the presentation, so please add any questions in the Q&A box, which can be found under the More button at the bottom of your screen. Alberta EcoTrust Foundation operates across Alberta, so we recognize the traditional territory of many diverse Indigenous peoples. This includes Treaty 6, Treaty 7, and Treaty 8 nations, the Blackfoot Confederacy, comprising of Siksika, Kainai, Piikani First Nations, and the Cree, Dene, Nakota Sioux, Saulteaux, and Métis nations of Alberta. These lands have been stewarded by Indigenous people for millennia who have maintained a deep and enduring connection to this land and its resources. We honor their histories, languages, and cultures and recognize the significant contributions they have made and continue to make to this region. As we carry out our work across Alberta, we commit to respecting and upholding the values and traditions of Indigenous communities who have lived and continue to live here. Alberta EcoTrust is a charitable organization advancing environmental and climate solutions across the province. Since 1991, we partnered with governments, industry, nonprofits, and Indigenous communities to mobilize resources, deliver innovative programs, and support projects that make a real impact. We're also a founding member of the Low Carbon Cities Canada Network, a national initiative that accelerates equitable climate solutions in cities through the Climate Innovation Fund. Through the Climate Innovation Grant, we fund organizations in Edmonton and Calgary working on low-carbon solutions, including the Retrofit Roadmap. This funding helps turn emission-reducing ideas into real-world projects. Whether it's technology demonstration, collective impact, or policy advancement, we support initiatives that drive innovation and deliver tangible benefits to communities. Ultimately, our goal is to strengthen and support those leading the way on climate solutions. We have two main programs focused on the built environment: the Emissions Neutral Building Information Exchange, or ENBIX, and the Retrofit Accelerator. ENBIX brings the building industry together to share knowledge, build capacity, and support sustainable building and renovation practices across Alberta. Our goal is to reduce emissions from both new and existing buildings. We do this by hosting events, sharing resources, and strengthening skills and training, peer-to-peer learning, and communities of practice, helping people and organizations turn ideas into real-world impact. Our other buildings-focused initiative is the Retrofit Accelerator. Through this program, we provide free coaching to help building owners navigate the entire retrofit process, from identifying opportunities to developing actionable plans and business cases, to connecting with service providers and accessing funding for studies. Eligible buildings include multifamily residential, commercial, and institutional properties. But due to high demand, we've currently paused intake for new applicants as our funding allocation has been reached. So for now, we encourage new building owners to join our wait list. Meanwhile, our coaches continue to support existing participants and are compiling the lessons learned from the program to strengthen future retrofits. I just want to take a moment to thank our ENBIX funders. The reason we are able to offer all of this for free is because of the amazing support from the cities of Edmonton and Calgary, Natural Resources Canada, LC3, Federation of Canadian Municipalities, Peter Gilligan Foundation, and RBC Foundation's Tech for Nature program. I'm very excited to introduce today's speaker, Peter Amerongen. Peter is a pioneer of net zero construction and the deep retrofit movement in Canada and a co-founder of Retrofit Canada. His commitment to energy efficient building began in response to the 1970s oil crisis, starting off a 45-year career in high performance construction. He's received numerous awards and accolades for his contributions. He continues to serve on several nonprofit boards. Peter has worked with several Alberta net zero building companies, including Habitat Studio and Butterwick Projects, and is currently working with Renew Engineering and Zoo House. So I'll turn it over to you now, Peter. think you're muted, Peter.
Thanks.
There we go.
Okay. I want to start by introducing our new executive director, Rebecca Pinto. We're thrilled to. She was our president for a while, and we were thrilled when she agreed to take over as executive director. She's got a PhD in building science from Carleton, and has also learned the hard way about retrofits by retrofitting her own house to pretty close to net zero. So um, Rebecca's going to handle the Q&A and many of the questions, but if I can share my screen here, I'll get started. So
Thanks, Peter.
is that okay?
Perfect.
Okay, so I want to start by thanking Enercan and EcoTrust and SSRIA for the help they've given us in getting this far. Enercan funded the Sundance Housing Co-op project, on which we learned a ton, and have through the GNPP program has enabled us to take our case study library and build it up, and they're also helping us to develop a solutions guide that will or starting they've given us a bit of help in that regard to and I'll talk about that down the road here. And EcoTrust for helping us develop the roadmap and just providing leadership and encouragement and being wonderful partners in all of this. And SSRIA for kind of the same thing. They also funded 3 single-family house projects that we did that were very instructive and are helping us with developing a kind of an IKEA system to deep retrofits. So I'm gee whiz. Okay. I doubt that you folks need to hear this, but like deep retrofits are not a choice. We really just can't make our GHG commitments without them because they're such a big chunk of global GHGs and Canadian GHGs as well. So just for housekeeping, when we talk about deep retrofits, we're talking about preparing a building for an emissions neutral future, basically by reducing the energy enough so that it can be powered from emissions neutral sources. And so why do we need a roadmap? Well, it's retrofitting this is a new undertaking. Basically, we've never tried to save a planet before, and it takes a new way of thinking. And we like to think that we've got as much experience as anyone in this. We've done feasibility studies. We designed and built the Sundance project and a number of other residential projects we've worked on. We've collaborated on studies in other regions in the country, and we've documented a bunch of them on all kinds of buildings, single family, multifamily, commercial. And even with all that experience, this is a work in progress. Like we're still learning from the buildings and figuring out how to do this. So I welcome any observations or comments from any of you about how we can do this better and any mistakes you think we're making. And in general, I want to start by kind of listing the problems that need to be addressed, and then have a quick look at a few of retrofits, and particularly what they've taught us, then look at the recipe that they suggest, and then talk about some shortcuts. So the roadmap tries to address some of the barriers to good planning that derail so many retrofits. And the biggest one is cost. So many retrofits never get off the ground just because they're so expensive. And while good planning is not a magic bullet, without it, the cost is even worse. And it also without that planning, you don't get the side benefits like catching up on a backlog of maintenance and paying it forward, healthy living, luxurious comfort, higher resale, all of that kind of stuff. You really need to plan to get all of those things. And opportunities also get missed. And some of the co-benefits, long-term energy security, renewed buildings, healthier living, and resilience in the face of extreme weather and fire. All these things need to be part of the planning process, and or they won't necessarily happen. And it's so complicated. We've got all these different building types to deal with, different construction, different eras, different sizes, shapes, starting conditions of insulation levels, alterations that have been done for them. And so in order to really practically deal with these, we need as big a range of solutions and details and techniques. And so far, the successful retrofits that we've interacted with have been done by, top-notch, experienced, innovative renovation contractors, net zero trained, and climate terrified. We need this roadmap for everybody else, for the army of people that are going to be doing this work that don't even know that yet. And while most of my examples are from residential construction, we've worked on enough non-residential projects to realize that the planning principles that we've learned apply to pretty much across the board. One of the first, besides cost, the habit that we've got in this country of piecemeal upgrades is another significant barrier that we've got to deal with. And my one of my favorite examples is a building that we encountered on the Sundance retrofit. It desperately needed new siding. They had the sense to know that that was an opportunity to add some insulation, but were talked into adding 3/8 of an inch of insulation by the siding contractor, who didn't want to deal with the with the trim around the windows. And so they missed the opportunity to make the building more airtight, to think about how the airtightness could tie into the other components. And when we did the deep retrofit, we covered that up. That money was completely wasted. In fact, it cost us money to deal with over what had been there before. And we see this, and I'll give a couple of other examples when I talk about the SSRIA projects. But one of the major problems is that most energy audits and incentives result in only isolated upgrades, rather than a comprehensive plan for zero. And even the EnerGuide renovation upgrade report that comes with every EnerGuide audit presents the improvements as isolated upgrades with no attention at all to how those might how those need to work together to get to any kind of an emissions neutral future. And it's really heartbreaking because the homeowners who are doing these upgrades are doing them with the best of intention and really thinking that they are on a path to zero, when in fact these upgrades often, once they're done, there's a sunk cost, and it makes it harder to change. And there are, in addition to these, there are other complications. Like there's a serious shortage of trained energy advisors and designers, contractors, and even architects and engineers. They just haven't had the opportunity to have the experience. And when we're and in some cases the humility to know that they don't know. And we've somehow got to do this. Basically, to get to emissions neutrality, it's almost invariably means we need to electrify, and somehow we have to add this huge load that's now being met by natural gas to the grid without blowing it up. And there are also risks associated with most upgrades. You change the heat and moisture flow, and you've got to be careful that you're not introducing damaging buildups that can undo your put you in a worse place than you started. So the Sundance project, we didn't realize it. I don't know how many of you know about it. It's an Energy Sprong inspired deep retrofit to a 1950s or 1970s townhouse complex in Edmonton that was intended but made possible by a research grant from Amerongen that really the co-op and we didn't know at the time, but the project was a result of a very fluky alignment of the stars. And it's only really by looking at other projects that we realized how fluky. We had a far-sighted, enlightened client who knew from day one that they were only going to do it once. They were on the verge of renewing their mortgage and their lease, and they knew that this was the only opportunity they were ever going to get to upgrade these buildings, and that anything that didn't get done now would likely never get done. And they took advantage of the retrofit situation to improve other aspects of the building. For example, every unit got a basement window that met fire egress. They had a couple of people who had kind of illegal bedrooms, and they realized that was not something they could continue, but that it would be prohibitive to do that as an individual project. But it was possible to do that, and a number of other improvements. And every step of the way, they made the hard choice and said, "Okay, this is forever. We got to do it." And they managed to do it basically with very, very little by good planning, good financial planning, very little impact on their ongoing housing charges. So we had that, and then we also had we had the team. We had the engineers from Renew Engineering, who are mostly mechanical engineers, but also do their own energy modeling. And a number of the partners have already done deep retrofits on their own houses. So there was a deep awareness of this, of the processes and requirements. So that was that, and the crew from Butterwick Projects had already worked on passive house projects, had a deep understanding of airtightness and all the gnarly details that are necessary to achieve that in a retrofit situation, and really uh, and then my own experience with net zero building and passive house training and all that kind of stuff. Um, and so those are what made it work, and those are what are needed in ongoing projects to make it remotely affordable. And just to give you a sort of a sneak peek at it, we did the full Energy Sprong thing with we learned how to do the digital scanning and take the scan to panel drawings, and I can't help bragging that every single one of our 350 panels fit. It was pretty amazing and pretty really fun. We we did the full envelope upgrade on it, putting a nice warm jacket around the whole house with off-site panels and the scissor truss roof over, and then we're able with that to get rid of the gas lines, put in air source heat pumps, HRVs and air source heat pump water heaters, and get very close to net zero and make life better for a whole bunch of people. So that was the other learning, is that people love this stuff. And then another project that was very instructive for us, just in terms of the variety of solutions that are going to be needed, was this three-house project funded by, subsidized by SSRIA. And on every single one of these, there people had taken subsidy money, made upgrades that we had to undo. And the top one, they had put on solar panels, and they'd had the sense to replace the shingles with the solar panels, but that was one that needed the roof to be built up over it. It had only a 2x4 for insulation space. So we ended up taking those off and throwing away the shingles and having to put put the panels back on. And the middle one, they had replaced the windows with, they were triple glazed, but they were very leaky sliders with very low performance specs, and we ended up replacing those as well. And on the bottom one, they had added R50 in the attic insulation without doing anything about the air tightness. And so it just really over and over kind of brought home the sort of the consequences of half measures. And we also learned from this project, we had three houses, three different roof treatments because of the starting points in those houses. And the one, as I mentioned, we stick framed over. The other one, we were able to do it with a stick frame or with a scissor truss like we did at Sundance. And the last one, we were able to suck out the insulation from the old attic and unfortunately discard it. They couldn't reuse it. Lay down some spray foam and put some back, which turns out to be a cheaper solution. And on the we from other projects, panelization is not super practical, and we still don't have a sort of a panel supply chain that makes it, ultimately I think that's where we're going, but because of the work involved in the digital capture and the transportation and the crane and all that stuff, it's still kind of a wash. So on a one-off basis, the wall build-up approach, site built is more practical. But there are a million ways to do that too. In the top left-hand corner is Stuart Fix's house that he did a number of years ago, where all the stucco was taken off and built a wall build-up was done kind of 1 2x4 at a time. The one below that is a modified Larson truss by a company in Calgary. Again, they took the siding off. We also have the option of rigid insulation with a rain screen. And in the bottom, the lower right is a project um, here on Saskatchewan Drive in Edmonton, where we're experimenting with assistance from SSRIA with a sort of an IKEA approach where we make pre-built studs and pre-built window boxes and try to speed up and leave the existing finish on. No, and so we need to collect all these ways of doing this kind of stuff, and I think because we can't go on inventing solutions for every project. So and then just to sort of give a sense of the range of projects that we're going to run into, this happens to be my house, was already pretty energy efficient, and all it needed was a geothermal system. It's not as energy efficient as the other projects we've worked on, but because the difference between where we were and where we needed to be was so small, the only thing that made sense really was the geothermal system, and then get the electricity from solar. So many lessons with that too, and also we ended up doing this with small equipment on a small site, and it's another thank you to EcoTrust. They're helping us fund a project where we are experimenting with directional drilling for installing geothermal systems without turning the site into a World War I battle zone. So that and then one of a project that really brought home how we need to think about these is one in Southern Ontario. It's for a couple that moved back from Edmonton. They to be closer to their parents in Southern Ontario, and they bought this house with the intention and with some assistance from us, with the intention of finding a house that would be suitable for a net zero retrofit. And they couldn't afford to do it all at once. And so we had to think about how to do it in stages. And the first step, as always, and it was to do an energy audit to figure out where it was going, and then have a close look at the house and see what it needed. And unfortunately, they had bought the house during the pandemic, and it had some pretty serious foundation. They couldn't get an inspection when they bought it because there was sort of bidders wars were going on, and they discovered after they moved in that they had some pretty bad leaks and it needed some work. So that was it was also in the energy model, one of the biggest heat loss areas. So digging it up to put in the weeping tile was an opportunity to insulate the foundation very easily. But while we did that, or they did that, we realized that that was that if the basement windows were done at the same time, you would never need to touch that again. So the idea, they did the insulation and the weeping tile, the windows, and fixing the grade all in one operation. Put a flashing on the top of the exterior insulation that was added, and then never touched the basement again. And the next phase was the attic. It was very poorly insulation, so big energy upside, and all it had in it was a bit of vermiculite and some isolated fiberglass bats kind of laying around. And they were uncomfortable with the vermiculite because of its asbestos content. And so the plan was to suck that all out of there, add 2.5 inches of spray foam to make it airtight. But before doing that, they took out the existing chimney and used that chase as a pathway to get ducting for a future HRV up into the attic and then run that over to pick up the exhaust from the kitchen and the bathroom. And then before the spray foam, that was all done before the spray foam so that the spray foam could encapsulate that and give them an airtight layer, basically the air barrier and vapor barrier for the house. And before that, actually, even they also installed a duct for future PV. So same idea, never touch it again. And when those two phases were being done, there was attention and details developed and attention paid to how the eventual wall uh, air barrier would tie in. But as it turned out, their air conditioner, which is not an option in Southern Ontario, died, and so they needed to do something about the mechanical system. And at that time, then they yanked out the furnace and put in the cold climate heat pump that would be sized correctly for after the walls and windows were done, and did the HRV and hot water tank at the same time. So they did that was supposed to have been the last phase, but it was moved up. And they ended up using, because the heat pump was a little bit undersized, they supplemented on a couple of cold days in that first winter with baseboard heaters. And then the last phase was the walls and windows that were easy to tie in because we thought about it. So, I think you can see this last phase was done this spring. I need to get some pictures of it. So from this, we've sort of derived what we're calling Deep Retrofits 101, which is sort of the foundation for the roadmap. And that is, you start by dialing in the best 2040 version of the building, considering how much, where the energy is going now, what the building needs or is likely to need in the way of improvement and maintenance, and then develop a plan to do that as efficiently as possible that's geared to the conditions and restraints that are associated with that building. For example, if it's an historic building, you might just say we're never going to get all the way. We're going to have to get just count on buying emissions neutral energy. But whatever it is, whatever the best 2040 version is, if you can't do it all at once, everything that you do, make sure it's to the 2040 plan, and do it in a way that anticipates the remaining steps, so they're never harder, and you're never redoing anything. So the sort of general recipe that comes out of that is the first step is to establish some kind of ballpark feasibility to make sure that it's a real project. And this can be a challenge while we're still in these early days. Find an experienced contractor or designer, energy advisor can help a lot, and that can be difficult depending on where you are. If you're in Edmonton or Calgary or Ottawa, a couple of other places in the country, they're getting to be some fairly well-established retrofitters that should be able to help you with that. Also depends a bit on the project type. On the bigger, more complicated projects, it's going to be hard to find these numbers. And we're also hoping that our case study library will be able to help with that as we go on. But once you've decided that you're going to go ahead, basically assemble a team, it's got to be some kind of integrated project delivery, like the where all of the major players come together and learn from each other and learn each other's problems and challenges and work out together that optimal solution. And it's a pretty big team. or can be. More and more, I think we'll find, as we did in the Sundance project, that several people can wear multiple hats and streamline that and reduce a lot of the talking. And then the next phase would be the information gathering, where you first of all kind of work out what the owner needs to get out of the whole thing, and what their predominant goals are, and what kind of assistance might be available for what they need to do, and then evaluate the building. So a building condition assessment, an energy model, identify upgrade possibilities. Where does it make sense to make changes? What can you do? And do we have the electrical service capacity to make that work? Can we adjust can we up the energy specs so that the energy service requirements are low enough that we can do it without a service upgrade, or at least not too big a one? And so with all of that information gathered, then there's an optimization process that's pretty gnarly. It involves taking all of that together, all the information you've gathered, and dialing in that 2040 optimum solution. It can be complicated and expensive, and on bigger projects, particularly, as I mentioned, if you've got people who uh, um, haven't got that much experience, and it's so critical to take a building as a system approach through all of this to avoid unintended consequences and create other problems. So it's we're not the only ones trying to figure out kind of this sort of roadmap, and it's we don't have time really to go into the sort of nitty-gritty of it. The more detailed approach, but SAIT has also developed a roadmap with us, which would help that looks something like this, that breaks down some of the steps a little bit more. They also have a terrific course that we help them develop to teach the basics of deep energy retrofits as sort of ongoing learning. And another work on this is being done in conjunction with the GNPP program that our library is being funded by, that can has basically the same steps but broken down into a lot more detail, and will be available soon. But it's fundamentally the same, a very, very similar process. The LEAP, the Enercan's local energy efficient partnerships program, has a tool that runs on HTAP that can do some of this optimization. And this is a plot of a house in Ontario. The varying colors of dot are different mechanical systems. The axis on the vertical axis is total cost of building ownership. The horizontal axis is percentage of energy saving, and the program runs thousands of iterations with variations to identify the lowest cost, best payback options. It's only as good as the costing data that they have in it, which is still a kind of a work in progress. But where you want to be is in the lower right-hand corner with the lowest cost and the highest energy savings. So this is all fairly daunting and a lot of work, but we see hope on the horizon for making it a lot simpler. Um, the some of the shortcuts that have come up or that we've become aware of right off the bat is there's a there's a study done by NAMA Canada, the North American insulation manufacturer. They put out a guide, and it was done by RDH, one of my favorite next to Renew Engineering, energy efficiency consulting engineers in the country. They ran optimizations for every climate zone in the country. So basically, if you have the opportunity to do a major upgrade in the building, roof, walls, you don't need to do that optimization. Just go to the NAMA recommended level and and you're done. The big cost is replacing the siding, and the incremental cost in going to the sort of the highest level in is relatively small. And the same goes for windows. If you're replacing the windows, the cost is in the labor and the frame. The incremental cost for high performance windows is relatively small. And all the way down the line, if you've got an opportunity to improve air tightness, get it as tight as you possibly can. Getting there was most of the cost. Once you're there, it's very easy to get into those really low levels. Same with cold climate air source heat pumps. Get the most efficient you can. Also HRVs. The incremental costs are low. It's the first cost that really is the biggest barrier. And so we also think that our case study library can be very helpful. We've got about I think we're on 60 case studies, a bunch more in the works, and it just makes it so much easier when you can find a precedent where somebody's already done it, and you get the before and after specs. In some cases, the costs, we're not always able to get the cost, the drawings, what was done, why it was done the way it was done, what problems there were, what could be done differently. So, for example, if you've got a house in Saskatoon, a semi-bungalow, same climate zone as Edmonton, you might find one in our library here where you could see exactly what was done, get and learn all that stuff right up front, right off the bat, and be so much further ahead. And also, see the beautiful new look and kind of see that there are other benefits to doing the whole thing. But as this thing is getting better and better, we're realizing that that nobody breeds anymore. Everybody that we have to make this much more accessible so people don't have to do tedious research, digging through a whole bunch of case studies to find the best solutions for them. So our current project, we're starting to develop a selection guide where we mine the case study library, do a little curation and pick out the best details that we think, and then link those to the conditions. We have in addition to a library of solutions, we also have a library of conditions that you might find and problems that your building might have, and so that you could go to the library or go to this tool, which we're thinking will be basically an icon, click on the house, and that will ask you a bunch of questions to ascertain what your situation is and what complications you have. And that would link to uh, retrofit assemblies that might work for your situation and the reasons why one would be better than the other. So we're looking for funding to take this all the way. We're doing we've got a sort of a pilot started, but we really think that building this out will make the whole planning process for retrofits a whole lot simpler. Um, and I mean, this is just a little illustration of what we sort of imagine it'll look like. Um, and I think I want to thank you all for being with me here and apologize that for the fact that this is still a work in progress. There's a lot more detail on our Retrofit Canada Learn page, and with that, I'd like to turn it over to Rebecca to uh, manage the Q&A and answer the questions, or some of them anyway.
Thanks, Peter. Well, thanks so much for your really informative and thorough presentation. So, like Peter said, this is the Q&A portion of the presentation. So feel free if you would like to raise your hand in the using the Zoom functions in the React menu, or if you want to type in your question into the chat. We also have the Q&A form enabled, so you can type your question in there as well. Or feel free to, unmute and ask your question the old-fashioned way. Okay, so we have our first question. Okay, yeah, so Kate's asking, how must Canada's financial and real estate appraisal systems evolve to unlock the retrofit economy? That's a great question, Kate. So I'll just jump in and I know that Amerongen currently has had a call for proposals out for something called the Home Labeling Fund, which would look at energy labels for homes, which currently exists in other jurisdictions around the world. And I think that especially on the real estate appraisal side, would enable people who have done deep energy retrofits or have more energy efficient homes to show that to people when they're looking for homes. So you're not just seeing the cost or the nice, bathroom fixtures, the nice kitchen. You're also seeing, oh, this house is getting an A for energy efficiency, and look at the average cost for utilities per month, for example. So I think that would allow it to incentivize the financial situation. And Peter, do you have any comments on that question?
Yeah, a few. In some countries, France, for example, there is mandatory home labeling. You get an energy score, and the little blurb on the real estate office window. Basically, you see with the picture of the house, you see the energy score. And I know with the previous government, when they were doing their research, their climate research, this is a previous the Alberta NDP government, that they actually, one of the things they heard most often was mandatory labeling, and they were close to doing that in Ontario, which I think would have led the whole country and probably made it easier to made it easier to implement, but it got killed by the Conservative government in Ontario. So I really think that and I don't know if the if the federal government has the authority to regulate that, but I think mandatory home labeling would make a big difference. We've worked with the appraisal folks at the Net Zero CHPA Net Zero Council, and there just isn't much appetite in the real estate industry for doing it. They see it as a nuisance, and people with buildings that would score poorly really, really don't want uh, to have to label their houses. So
Yeah.
I'm not sure if that I think we need to you know to make progress and the banks are toy with it, but they follow, unfortunately, the sort of general tone of the populace, I think, and those concerns kind of ebb and flow.
Thanks, Peter. I'll also add that more jurisdictions are coming out with in Alberta, I believe it's the PACE program. In other jurisdictions, it's PACE in other jurisdictions and SEEP here in Alberta. Maybe I'm confusing that, but basically where it allows you to tie renovations to your property and then paying it back through your property taxes. And so if you sell your home, the new homeowner will also assume that. And so that also makes it easier for people so they're not sinking the entire cost in upfront and not knowing if they'll move or not. So, okay, so moving on. So Zoran Popovich sent me a question and he asked, who is the deep energy retrofits manager or team leader? So which type of person would be that manager or team leader? And then what type of contract would apply? Would it be the Canadian Construction Document Committee? And how soon would subtrades need to be involved in decision making? So, Peter, do you want to take that?
Well, that's kind of three questions.
Yes.
Um,
Okay, the
the
first one is who would be, yeah, the manager or the team leader? What kind
so
of person?
and in these early days, that depends. I would say uh, who's done it before and who's got the deepest experience. Sometimes that'll be the contractor, sometimes it'll be the architect, engineer, designer. It really depends on sometimes it will be a sort of a dedicated retrofit coach on single family housing. It can be either the contractor or the energy advisor, whoever really has the best handle on it. So in a bigger project with a formal IPD, you probably would have an like a retrofit coach that would manage that. But
And
however you get it done, yeah.
and Peter, how soon should subtrades be involved in the decision making?
Again, I think it depends on the overall team experience. The less experience on the team, the earlier they better be there, and also depending on their experience, if they've done it before. Um, there's a good chance they don't need to sit in on the early meetings.
Yeah,
But
and I'll go ahead.
yeah, and again, it depends a bit on the scale too. Like if it's a single family house, you want to have a site visit with all the potential trades pretty early in the situation.
Yeah, I was just going to add, based on my own experience doing our deep energy retrofit, that last question about the what type of contract applies, we did, our contract, our contractor was a general contractor who had actually worked on deep retrofits before, um, actually with Peter. So he had a really good understanding of what was needed and the details that were involved. So he actually, we took about a year to do the planning process with him, and we chose the subtrades with him, and he kind of managed all that. But we did have a CCDC contract. Okay, so
And just to
there's
add,
yeah,
there is
go ahead.
and I can't remember the number, but there's a CCDC progressive design build contract that I think works quite well.
Okay. So there's a question. Well, I'll just there's a couple comments in the chat. So Donna Davies Brackett says that she lives in the UK and they do have a scoring system for labeling houses, but it's not as effective as you might expect, especially if all your neighbors have the same rating as you, then there's no pressure to move your rating. So yeah. And then there's also the issue about how the rating is assigned. So um, and then Meredith has in the chat about also the renovation contract. Andy Cockburn has asked, so there's a lot of people, there's a lot of industry superstars, as Andy says, on the line today. How can we best help Retrofit Canada and the roadmap throughout 2026 and into 2027? So Peter.
Oh boy, thank you, Andy. Let's I, let's have a look at who's there and what interest there is in collaboration. That would be fabulous. I I know of a couple others. I mean, I don't know who else on the call, but that's a great idea.
Yeah, and I think getting the word out about these tools. So Retrofit Canada's goal as an organization is really, to help consolidate and then also help disseminate in an open source and a free way all the tools for retrofits. And I know that there's a lot of, like Amerongen Leap has tools and other websites have tools. And so, as we grow, that would really be our focus is to, help develop and then, maybe link to these tools or have like a one-stop shop approach for both builders, homeowners, everyone who wants to retrofit and learn about retrofits. So that's our goal.
Yeah, and there's a sort of a conundrum that I grapple with. On the one hand, it looks really dauntingly complicated. On the other hand, after you've done a few, I had an experience in the city of Hamilton. The city of Hamilton is looking at retrofitting a uh, some of their nonprofit housing townhouses and asked me to have a look at them. And I was sort of shocked watching myself just because of the benefit of the experience that I had in all these other places. It was just like bang, bang, bang. This is what you do here. This is what you do there. This is what needs more study. I've never seen that before, but it's not really that complicated. It's not rocket science. It's uh, which is why I think it's so important to collect these lessons and make it so that they're so everybody has the benefit of them.
Yeah, thanks, Peter. And I'll put in so yeah, we're just coming to the top of the hour here. So I'll just put in a final plug and as we're looking for more funding in the coming years, maybe we'll reach out to some of the people on the call and ask for letters of support, and that would be a great way to support us. So with that, I'll pass it back to Kate, and thanks everyone.
Yes, thanks so much for your presentation today, Peter and Rebecca, and thanks to everybody for joining. The session will be available soon on enbix.ca under the resource library section, and we hope to see you at a next event soon. Have a great day.
Thanks.
Thanks, Kate. Thanks, everyone.